Hi everybody, this is TheGreenFrog here, and welcome back to another video. Today I'm going to be doing another math video, and I'm going to be talking about integer exponents, meaning when you have a number raised to an exponent that is an integer, basically a whole number that can be positive or negative or zero, and I'm going to be discussing all three of those today. So even if you don't remember what a normal, how to evaluate an expression with a normal positive exponent, then I will go over that stuff as well. So we're going to start really simple. So if we have something like 4 to the third power, and you can see it's 4 here, and then I'm going to be saying to the third power because that's the 3 up there. This is the base down here, and that's the exponent. So if we have something like this, basically what it means is we're going to have 4 being multiplied, and it's going to show up 3 times. So it would be like 4 times 4 times 4. The 4 down here is why we have the 4's, and then because there's a 3, there are 1, 2, 3 4's. A lot of people might like to say it like it's 4 being multiplied by itself 3 times, but I don't really like that because it sounds like 4 being multiplied by itself once, twice, 3 times, and that's wrong. Like you might say 4 multiplied by itself once, twice, 3 times, but that's wrong because that's 4 4's. When you have 4 to the third power, you only want 1, 2, 3 4's. So 4 to the third power is just 4 times 4 times 4. They're all 4's because of this 4, and there's 3 of them because of this 3 up here. So that's a basic exponent. And then, so obviously if we were to do something like 3 to the 5th power, then that's 3 times 3 times 3 times 3 times 3. And if we just did something simple like 4 to the third power again, that's 4 times 4 times 4, which is 64. So that's how you would do a simple exponent like that. And if you have like 2.5 to the third power, it's just 2.5 times 2.5 times 2.5. Now, something very important to note here, if we're talking about negatives, there's a huge difference between some different ways you can write these things. So you might think negative 5 to the second power or negative 5 to the second power. They seem like they're the same thing. It seems like both of them are saying you take the number negative 5 and you put it to the second power. That's not what both these mean. Remember order of operations. Parentheses, now parentheses doesn't matter here because this is parentheses, but it's already solved inside, so that doesn't apply. Exponents is next. When you have negative 5 to the second power, that's basically, like if you have like negative 4, that's really the same as negative 1 times 4. So something like this, think of it as negative 1 times 5 squared. And then you'll realize, in this case up here, you're not doing negative 5 to the second power or squared. The second power is squared into the third power is cubed. If you have something like this, that's not what you're doing. Because of order of operations, you have to do this 5 squared first, which is 25, and then you take the opposite of that, so you put a negative in front. This one, on the other hand, these parentheses say, I don't want the opposite of 5 squared. I want negative 5, that whole number taken to the second power. And in that case, negative 5 times negative 5 is positive 25. So you see, negative, positive, 2 different numbers. Make sure that you're paying attention to whether you have parentheses or not. If you have a negative base, negative number that's being raised to a power, because it can affect your answer in terms of negatives and positives. So now on to just some basic things to know. If you have 10 to some power, like 10 to the 5, just write 1 and then write 5 zeros. So 1, 2, 3, 4, 5, and then you can go boop, put the comma in there, and then that's simple. It's 100,000. If you have any number to the first power, so any number here to the first power, like 4 to the first power is just 4, 0 to the first power is just 0, negative 2 to the first power, or should I say negative 2 in parentheses to the first power is just negative 2. So x to the first power is just x. Even with something like 0, it's basically saying 0 written out in multiplication one time. Well, there's 1 0, so of course it's 0. Now, there's a few other things here. Anything to the 0th power, except when x is 0, is going to be 1. So, 4 to the 0th power is 1. Sounds kind of weird, but that's how it works. Negative 2 to the 0th power is also 1. Positive 1. Now, if you have 0 to the 0th power, we're not really going to worry about that, because you might say, well, 0 to any power. Oh, I didn't actually talk about that yet. I should mention that as well. 0 to any power where x is not 0 is just 0. Like, 0 to the 4th power is just 0, because it's 0 times 0 times 0 times 0. It's just a bunch of zeros. Or 0 to the 19th power is also just 0. But we don't want to worry about 0 to the 0, because we could say, well, 0 to any power is 0, or we could say 0 or anything to 0th power is 1, and then you have 1 or you have 0. So we're just not going to worry about that, because that's a debate for another time. So, okay, so now we're going to move on to negative exponents. So if you notice the pattern here, like if we use 2, like 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 1st, 2 to the 0, and then we're going to worry about 2 to the negative 1, 2 to the negative 2. Now 2 to the 3rd we know is 8, because that's 2 times 2 times 2. 2 to the 2nd is 4. 2 to the 1st is 2. 2 to the 0th is 1. Now if we look here, divide by 2, divide by 2, divide by 2. Gives you a little hint. It's going to be a half. It's going to be a quarter. Now how that works is if we have something like some number to the negative something power, then that is the same as 1 over that number to the positive version of that power. So if we use an example like 4 to the negative 2 power, then that is the same as 1 over 4 to the 2nd power, or 1/16. If we have 5 to the negative 3rd power, then that is the same as 1 over 5 cubed. Get it here? You just take this number, put it here, take the positive and put it here. So it's just 1 over the number to the positive version of that exponent. So this would be 1 over 125, because 5 times 5 is 25, and 25 times 5 is 125. So that's how a negative exponent works, and it would work like that for most numbers. Something to note here, take a look at 0 to the negative 2, for example. That's 1 over 0 to the 2nd power, which is 1 over 0. We don't like to divide by 0. So that would be either, it's probably undefined, or just something we're not going to talk about. So I'm just going to clear all this stuff off real quick. Sorry if I'm going through a little fast. I just don't want this to be a really long video, and I have some stuff to cover, like some more complicated expressions and stuff that I want to make sure I have time to do without making this into a half-hour long video. Hopefully you understand everything I've said so far. So just to recap, like 4 to the 3rd power would just be 4 times 4 times 4. And if we had something like 4 to the negative 3rd power, that's the same as 1 over 4 to the 3rd power. So the top one would be 64, and this one would be 1 over 64. Now, again, that whole negative thing still applies here. Negative 4 to the negative 2 power, or negative 4 to the negative 2 power. Notice I'm using an even exponent here to show this example, because if you have an odd exponent like this, right? If you have this as a negative with parentheses or without it, think about it. Negative times negative times negative is going to be a negative. So that would be like negative 1 over 64. But if you put it in front, then it's 1 over 64, take the negative again. So it's still the same thing. But when we have an even exponent, this is where it differs. So if we have something like this, then this is going to be 1 over 4 to the second power, but make sure we put that negative in front, because this negative is not attached to the 4. We want to do exponents first before we do multiplication, because it's basically -1 times. We do exponents before we do multiplication in the order of operations. So we're going to be doing this first, and then we're going to be taking the negative of it, versus this case, we're going to have 1 over -4 squared. So this is -1/16, and then here, this is +1/16, because if we have -4 squared, that's -4 times -4, and that becomes +16. So again, these answers differ, so make sure that you're paying attention to that. So now we are going to be moving on to some more complicated stuff, because we know how to do positive exponents, negative exponents, and exponents to the 0. So now we're going to be trying to do some equations, or should I say expressions, with exponents along with other stuff. Thing to note first, something like this, 4 to the 3 plus 2 to the, I don't know, third power or something. Something like that. Something to note here is that you don't want to distribute this. Do not try to distribute, because it's not necessary for what we're doing here. What we should do is we should solve this first. So 3 plus 2 is 5, so it's 4 times, or it's really, just to do this, 4 in parentheses 5 to the third. Same thing applies as with the whole negative thing here, kind of. We're not going to be doing 4 times 5 and then take it to the third power, because it's not like we have parentheses here. If we had that, then that's what we would be doing. But remember, exponents comes before multiplication, so we want to do this first. 5 to the third power is 5 times 5 times 5, which is 125. So 4 times 125 is the same as 500. And that is how we would do something like that. And then obviously if you just have some addition or subtraction afterward or whatever, then you just do that afterward, like you would solving a normal expression. So now let's try to do something a little bit more complicated here. Like if we had 3 to the third power plus, we'll say -2, or we'll do minus here. Do minus -2 to the 0th power minus 2 to the 5 minus, or we'll do plus 4 to the -2 or something like that. So how would we try to tackle something like that? Well, first of all, you might notice here there's none of that weird stuff we just covered. So if you have anything like that with like the number outside of the parentheses and then stuff inside and then the exponent, make sure you do it how I just showed you. But for something like this, we don't have anything tricky like this. We just have to go step by step. So first we want to do parentheses. So we'll just do 3 to the third minus -2 to the 0th power. We're trying to solve inside these parentheses. So 2 to the 5th is 2 times 2 times 2 times 2 times 2, or 2, 4, 8, 16, 32. 32 plus 1 over 4 to the 2 is 1 over 16. So this ends up being 32 and 1/16, just like that. And then I'll just clear this off so we have some room here and slide down. Now next we want to take care of the exponents. So 3 to the third is 3 times 3 times 3, or 27. So 27 minus, and then here we have -2 to the 0th. Now notice this negative is inside the parentheses, so we want to do the whole thing to the 0th. And remember, anything except 0 to the 0th power is 1. Now we're going to subtract 32 and 1/16. And from here it is just some simple math. So 27 minus 1 is 26, minus 32 and a 16th, which basically means we're going to do minus 32 plus 1/16, which is the same as saying, if you notice a kind of a application of this distributed property here, 26, I'm just going to show this in detail so you don't get confused. 26 minus 32 and a 16th is basically saying 26 minus, and then 32 and a 16th is the whole number. It's the same as saying 32 plus 1/16. Now, if we use the distributed property, saying this negative 32 plus 1/16, that's basically the same as saying negative 1 times 32 plus 1/16. So this is the same as saying 26. Now, negative 1 times 32 is negative 32. Negative 1 times positive 16 is negative 16. Or 1/16 is negative 1/16, sorry. So we're going to have that right there. And that takes care of that. So now, instead of trying to subtract this mixed number, there's no need to make the whole thing into 16ths. Like, imagine like trying to make 32 and a 16th all into 16ths and then 26. That would take way too long. So we're going to do this instead. 26 minus 32, if we flip it, 32 minus 26 is 6, but because the negative 32 is bigger than the positive, the negative is bigger, so it's going to be negative 6 minus 1/16, which of course is negative 6 and 1/16, because that's saying negative 6 plus 1/16, which is actually distributes to exactly that we have up there, because that's saying that this entire mixed number is negative. And there we go. This expression we had up here goes to negative 6 and 1/16. So I think I've covered everything. If you have a question, feel free to leave it in the comment section of this video, and I will be sure to check those out, especially if they're soon after I've released the video. I will make sure to answer those questions as soon as I can. And if you have like a correction or something, just of course leave it down in the comments, or just a comment in general, and I'll try to read through those, or if you're confused about anything. So I hope you enjoyed this video. It should have taught you how to do positive exponents, negative exponents, and stuff to the 0th power, including more complicated stuff like this. So I hope you enjoyed, and I hope you learned a lot from it. Please leave a like on this video, and please subscribe to my channel. Stay tuned for future videos, math videos or not, and I'll see you next time for another video. Goodbye!